Hello everyone, a very good evening to all. Once again, I welcome you all for this sixth interaction session on atomic and molecular physics, atomic and molecular physics course, which is being flowed this July 2025 session on NPTEL with course code NOC 25 PH04. Myself, Vivekananda Naik, I am a PhD research scholar in the Department of Energy Science and Engineering, Plasma Physics Laboratory, IIT Delhi. So today we will discuss a few problems that will again cover the 6 week lectures talking about the course contents of this week. So the course lectures were about multi-electron atoms. So in multi-electron atoms, so when there are more than one electrons, so how these electrons are arranged and how the interaction between spin angular momentum and orbital angular momentum result in a number of cells and how the energy levels are arranged and the electrons are arranged in different energy levels according to a few principles like Hund's rule, Abbas principle. We also need to consider Pauli's exclusion principle, which states that no two electrons in an atom can have all four quantum numbers equal. Then, in order to treat the hydrogen atom, in order to get more information about the structure of the atom of hydrogen, then quantum mechanical approach was also discussed. So there are some basic introduction about quantum mechanics, and then quantum mechanical treatment of hydrogen like atoms was also covered in the week's lecture. So talking about, so I will first give you a brief introduction to quantum mechanics, and then we will start solving uh, the sample questions that will help you in solving the assignments as well as in your exams. So if you talk about quantum mechanics, basically there were a number of drawbacks of classical mechanics. For example, if you talk the case of black body radiation, so if we talk about black body radiation, we have already discussed that the black body radiation curve was not um, so there are different laws that were given to fully describe the black body radiation curve. However, the one that was given by Planck was able to give the complete explanation of the whole region, that is covering all the wavelength and frequency regions of a black body radiation curve. So there are a few things that was not that classical mechanics was not able to explain. However, due to the introduction of quantum mechanics, those topics were explainable. Another example might will be photoelectric effect, photoelectric effect. Then, if we talk about Compton's effect, so there are a few things that was not explained by classical mechanics. However, quantum mechanics was able to explain. And if we talk about some uh, important aspects of quantum mechanics consider wave particle duality. So wave particle duality. So we say that each matter particle has associated with, so each matter particle is associated with wavelength which is called as de Broglie's wavelength. De Broglie's wavelength. Now, if we talk about the de Broglie's hypothesis, it was lambda equals to h by mv. So this is the wavelength. Then this is Planck's constant, and this is the velocity or the momentum, we can say momentum of the particle. Again, according to Planck's law, so this was about de Broglie's wavelength. Again, according to Planck's hypothesis, he said that the light is not continuous. It contains some discrete energy packets, and each energy packet is called as quanta, and from that quanta it come the name quantum mechanics has been also derived. So this was again the Planck's constant is value 6.64 into 10 to the power minus 26.62 into 10 to the power minus 27 joule into second, and this is the frequency. So the frequency is equivalent to energy, and the energy is also quantized. So basically we can say E is equals to nh nu, where n is 1, 2, 3 like that. So uh, with the evolution of a few if, with the evolution of a few things, quantum mechanics gradually got developed. So basically, the most noticeable difference in classical mechanics and quantum mechanics is in quantum mechanics, each state of the particle is expressed in terms of a state vector, which is called as wave function. So quantum mechanics is based on the wave function. So it basically explains a state of the particle, that is the particle is present in a state and the state has some wave function. So if we try to write in terms of notations, this is called as Dirac notation. Dirac notation of quantum mechanical states. Similarly, if we talk about any physical quantity like we have in classical mechanics, mass, energy, momentum, all that things, then that physical quantity is explained like star, and this is in Dirac notation, it is written as this. Talking about the relation, we can write this psi and phi as psi phi, where psi is being operated on this state phi. So also this means that the integration psi star x phi x dx. So integration you can also impose limits on the integration. Similarly, if we write psi, then it will be psi star x psi x dx, which is again psi x mod square dx. Now, as I told, the physical quantities that are represented in terms of operators. Let me first add another slide. So, for example, suppose there is a physical quantity, it is represented by operator A. So, if you talk about the operators, operator A is written as A cap, and when that operator gets operated on a state, then the state becomes psi star. The state can change or it may not change. When the state does not change, we can write A cap psi equals to A psi. Then this is called as eigenvalue equation, where this psi is called as a eigenstate of the operator A cap, and A is called as eigenvalue. And if you talk about some operators, for some of the examples are x cap is the position operator, the momentum operator has the for minus I h cross d by dx. Some operators like Hamiltonian operator, we can write p cap square by 2m plus v x2, we can say, or we can write minus h cross square by 2m del square by del x square plus bx or bx2, we can write. So this gives momentum, and this gives total energy. Now, since we are considering about operators, so there are specific type of operators which is called as Hermitian operators, and those operators have real eigenvalue. So all most of the physical quantities are expressed in terms of Hermitian operators, like position operator is also Hermitian, momentum operator is also Hermitian, and Hamiltonian operator is also Hermitian. If we are talking about some physical quantity, so if you want to find the expectation value of the operator, so we can write it psi a cap psi divided by, or the probability of finding a particular state, we can write this is expectation value, and probability can be written as psi n psi divided by psi. So this is the probability. And so as I told you that each and every state is expressed in terms of a wave function. So the equation of motion in classical mechanics, we have a equation of state which is called as Schrodinger's wave equation. So for any state, we can write Schrodinger wave equation which has the form h psi is equal to e psi. So you can write L square psi x by a square plus Vx psi x equals to E psi x. So this is kinetic energy term, this is potential energy term, this is the total energy, and this equation is called as Schrodinger's wave equation. These are a few things that I wanted to discuss with you about some introduction to quantum mechanics. Now, if we now let's start solving a few problems that are based on these concepts. So the first problem says, consider a one-dimensional box of length A having 3 electrons. What is the lowest energy of the system? Where the notations have their usual meaning. The options are option A 3h square by 8ma square, option B 3h square by 4ma square, option C 9h square by 8ma square, and option D 2h square divided by ma square. So the question says, consider a one-dimensional box of length A having 3 electrons. Now I will give you a few minutes to try this, and then we will discuss how you will solve this problem. So this problem says, consider a one-dimensional box of length A having 3 electrons. So basically this is a type of one-dimensional potential, so which is also called as one-dimensional infinite potential well. So this potential has the form, so Vx equals to infinity when x less than 0, 0 when x 0 to a, again infinity when x is greater than a. So here it is saying that the length of the box is a. So how the potential will look like? It will be, so this is infinity, this is infinity, this is 0, this is a. So x is along this direction. So from 0 to a, the value of the potential is 0. So when the particle is present inside this box, then it can't escape the box, which is also, that's why the potential is also called as potential wells. So now if we write the equation of state, so we can write it like, if we write the Schrodinger's equation, so it will come out to be d square psi x by dx square plus k square psi x equals to 0, where k is 2me divided by h cross square root over. So now if you talk about the solutions, then the solutions of the wave function will be of the form psi x will be a sin kx plus b cos kx. But these a and b are constants, so these a and b can be determined from the boundary condition. So this is the solution, and what is the boundary condition? So since the particle can't escape the box, then we can write psi x at x equals to 0 is 0, and psi x at x equals to a is 0. So in that case, if we solve, we will get kna equals to n pi, or k is n pi by a, where n starts from 1, 1, 2, 3, because n can't be 0, because when n equals to 0, then psi x equals to 0. That means the particle is not present. The particle is not present, so it is not valid. Since we are talking about the states of the system, then the particle should be present there. So since the wave function is becoming 0, so the particle can't be present. That's why n can't be having the value of 0. Now talking about the energy, we know energy has the form p square by 2m, or you can write h cross square by k square, h cross square k square by 2m, or we can write h cross square pi square n square divided by 2m a square, where a is the length. So now, as we have already, um, so this is the energy of the nth state, where a is length of the box and m is the mass of the particle. So now the question says, consider a one-dimensional box of length having 3 electrons. What is the lowest energy of the system? So the lowest energy will be the ground state energy of the system. So the since we want to find out the ground state energy, so the value of n will be again the lowest value. So for lowest energy, that is ground state energy. So what will be the value of N? Here you see the question says it has 3 electrons, and according to Pauli's exclusion principle, what we have? Pauli's exclusion principle. Since electron has spin half, 2 electron can be present at max in one energy level, is not it? So suppose this is the box. Again, since n is not 0, so we will start the ground state here. This is n equals to 1, then n equals to 2, n equals to 3, n equals to 4. So here if you see, the gaps are not even, because if you see the first the expression is E is directly proportional to n square. So the energy levels will be having different uh, delta E. So since we are talking about 3 electrons, so 3 electrons, so this can't be an energy state. So 3 electron means 2 electron will be present here and 1 electron will be present here. And if 2 electrons is present here, so the total energy of the system will be 2 into E1 plus 1 into E2. So the energy of the system will be, we know the energy value is n square h cross square pi square by 2m a square. So for n equal to 1, it will be h square by 8m a square plus h square by 8m a square plus 4h square by 8m a square. So n equals to 1 here, n equals to 1 here, n equals to 2 here. So if you add it, it will be 4 plus 1 plus 1 6. So it is 6 h square by 8 m a square, or 3 h square by 4 m a square. So this is the correct answer. So the correct option is option B. So when we consider 3 electrons, then the lowest energy of the system will be 3 a square by 4m square, which is the ground state energy, which is also the ground state energy, because we know ground state energy is the lowest energy of the system. Now I hope this is clear to everyone. We will move to the next one. The question says, in previous question, if there are 10 electrons and box length A is 1 Armstrong, calculate the lowest energy of the system in joule. Options are: option A 2.07 into 10 to the power minus 16 joule, 3.5 into 10 to the power minus 15 joule, 4.1 into 10 to the power minus 14 joule, and option D 5.3 into 10 to the power minus 17 joule. So I'll give you a few minutes to try this, and then we will discuss. So here the question says there are 10 electrons. So how we will arrange those electrons? We know maximum 2 electrons can be present in one energy level. So this is n equals to 1, n equals to 2, n equals to 3, n equals to 4, n equals to 5. So 2 will be present here, 2 will be present here, 2 here, 2 here, and 2 here. So how we will calculate? So we know the value of energy given by n square h square by 8 ma square. So we will add these energies. So since each state has 2 electrons, so the total energy will be 2 into h square by 8 ma square. Then n will be 1 square plus 2 square plus 3 square plus 4 square plus 5 square. And we have the values also. In the previous question, it was the options were like h square by 2 ma square, all that, but here you have the values. So the value of A is 1 Armstrong, that is 1 into 10 to the power minus 1 into 10 to the power minus 10 meter, and mass is also known to us because these are electrons, and the mass of electron is 9.1 into 10 to the power minus 31 kg. So what will be the total energy? So it will be h square by, sorry, it will not be, so it are 2 and 8, they will cancel, it will be 4, h square by 4 m square, h square by 4 m square, 1 plus 4 plus 9 plus 16 plus 25. So it will give us 25 plus 16, 41, then 41, and these are 14, 41, 14 is 55. So it will be 55 by 4 h square by ma square, 55 by 4 into, if we put the values of h, it will be 6.62 into 10 to the power minus 34 whole square divided by 9.1 into 10 to the power minus 31 into a is 1 into 10 to the power minus 10 square. So if you calculate it, the value will come out to be 6.6 7 into 10 to the power minus 16. 6.7 into 10 to the power minus 16 joule. So this is the correct answer. And if you see the options, no options matches with the answer. So but the correct answer is this one, 6.7 into 10 to the power minus 16, or 67 into 10 to the power minus 17. This is the correct answer. Now we move towards the next one. The next question says, consider a particle of mass m moving in a field of force with potential energy U and total energy, that is kinetic energy plus potential energy E. If the de Broglie wavelength holds good for this particle, then its wavelength in terms of m, u and E will be, options are option A, h divided by E minus u into m, h divided by m root over of u square plus E square, then mh divided by root over of E minus u, or option D, h divided by root over of 2m times E minus u. So this question is related to the de Broglie's wavelength, and we have already discussed the de Broglie's postulate that was given by de Broglie, who said that each materialistic particle is associated with wave, and the wavelength is given by a formula, and that formula is lambda is equal to h by mv. Lambda is h by mv. So we will use this concept, and it will and the available quantities that have been given in the problem, that is mass m, potential energy is u, and the total energy is E. Then from these informations we will calculate what will be the wavelength. So I'll give you a few minutes to try this question, and then we will discuss how we will solve it. So let's solve this question. So according to de Broglie's hypothesis, lambda equals to h by p, we can write, where p is momentum, this is the wavelength. Now in our question it is given to us that potential energy is U, total energy is E. So E is total energy, U is potential energy, and M is mass of the particle. Now we know H is, sorry, don't need H. So lambda is H by P, and we know the kinetic energy and momentum has the relation. If the kinetic energy is K and momentum is P, K is given as P square by 2m, because we know kinetic energy K is half mv square, so half m square v square by m, or half p square by m, which is p square by 2m. Now K is p square by 2m, we know total energy is kinetic energy plus potential energy. So kinetic energy K will be total energy minus potential energy. And in our question, total energy is E, potential energy is U. It will be E minus U. So P square by 2m is E minus U. P square is 2m into E minus U. That implies P is 2m E minus U root over. So lambda is H by P. That implies it will be H by 2m E minus U root over. So the correct answer is H by 2m E minus U root over. So the option is option D, H by 2m E minus U root over. So I hope this is clear to everyone. Now we will move to question number 4. Question number 4 says, find the angle between the orbital angular momentum vector L vector and spin angular momentum vector S vector for the 2D 5 by 2 term, or 2D 5 by 2 state in one electron atom, where the options are option A 39.4 degree, option B 21.7 degree, option C 61.9 degree, and option D 87.5 degrees. So these type of questions we have solved in the previous interaction sessions. So in one interaction session, as much as I can remember, we also derived the expression how we can calculate the angle between L vector and S vector. So if we remember the formula, it's okay. Otherwise, we can again discuss how we will derive that formula, and then correspond to this particular state, that is 2D 5 by 2, we will calculate the angle between L vector and S vector. So I'll give you a few minutes to think about this question and try it, and then I will discuss. So let's solve this one. So it says the angle between orbital angular momentum L and spin angular momentum S. We know, according to the law of vector addition, J vector is equals to L vector plus S vector. So J square will be J vector dot J vector, that is L vector plus S vector dot L vector plus S vector. So if we derive it, so it will give L vector dot S vector is equals to J square minus L square minus S square divided by 2. We know L vector dot S vector is L S cos, that is the angle between L vector and S vector, equals to J square minus L square minus S square divided by 2. So cos L vector S vector will be J square minus L square minus S square divided by 2 L S. These, so L is nothing but L vector mod. So now for this, for the state 2D 5 by 2, D means L equals to 2 because S P D, so L equals to 2. Again 2S plus 1 is 2, that implies S is half. Also this is 1 electron system which is given in the question. So L is 2, S is half, and J, as you can clearly see, J is 5 by 2. So if we put these values in the equation, so theta, which is the angle between L vector and S vector, will be J square minus L square minus S square divided by 2LS. And again we know, according to the quantum mechanics, J vector mod is J into J plus 1 root over H cross. Similarly, L vector mod is L into L plus 1 root over H cross. And S vector mod is S into S plus 1 root over H cross. So H cross, both in the numerator and denominator, H cross square will get cancelled out. So we will be having cos theta is equals to J into J plus 1 minus L into L plus 1 minus S into S plus 1 divided by 2 into L into L plus 1 root over S into S plus 1 root over. Because in the numerator it was J square L square S square, but in the denominator it was L and S. So L and S means it will be root over of L into L plus 1 and S into S plus 1. It will be 5 by 2 into 7 by 2 minus 2 into 3 minus half into 3 by 2 divided by 2 into root over of 2 into 3 times root over of 1 by 2 into 3 by 2. So if you calculate it, it will come out to be 2 by 9 root over. So theta is cos inverse 2 by 9 root over, which is 61.9 degree. This is the answer. Now if we see the options, option C is the correct option, that is 61.9 degree. So this type of question we had already discussed in the previous interaction sessions also, so I don't think there will be any problem solving this problem. Now we will move to question number 5. So question number 5 says, for a two atomic electron system, the orbital quantum numbers are L1 equals to 1 and L2 equals to 2. Write the all possible values of the total angular momentum quantum number J under LS coupling. Options are option A 0, 1, 2, option B 0, 1, 2, 3, option C 0, 1, 2, 3, 4, and option D 1, 2, 3, 4. So I'll give you a few minutes to try this question and then I will discuss. So before we solve it, we should keep that in mind. In the question, it is given that it is a two atomic electron system. Two atomic electron system. So L1 is 1, L2 is 2, S1 is half, S2 is again 1 by 2. Because these are electrons and for electron S is half. So now again we will find the all possible values of total angular momentum quantum number J under LS coupling. So what happens in LS coupling? So in LS coupling, as the name implies, it is capital S and capital L and capital S. So all orbital quantum numbers will be first added, then in the next step all spin quantum numbers will be first added. There will be vector additions and then there will be coupling between total L and total S. That's why it is called as LS coupling. Then we will be having values of J. So now talking about the LS coupling procedure. So since L1 is 1, L2 is 2, so L, which is the vector addition of L1 plus L2, it will be having values as we have already discussed few times. So L1 plus L2 mod, L1 minus L2 mod with one increment, because this is how the vector addition works. It will be 2 minus 1 mod, 2 plus 1 mod with one increment. So 2 minus 1 is 1, then 2 plus 1 is 3, so it will be 1, 2, 3. So the values of L or the possible values of L coming out of coupling between L1 and L2 is 1, 2, 3. Similarly, for S it will be S1 plus S2, that is S1 minus S2 mod, S1 plus S2 mod. Since both are half, so it will be half minus half, half plus half. The possible combinations are 0 and 1 because there is no integers in between 0 and 1. So the possible combinations of s will be 0 and 1. So s will be 0 and 1. L will be 0. Sorry, L will be not 0, 1, 2, 3. Now let's do the last step, that is calculating the value of j from ls. So due to ls coupling, so L is 1, S is 0, S is 1, L is 2, S is 0, S is 1, L is 3, S is 0, S is 1. So L1 S0 will give 1 plus 0, 1 minus 0, only 1. So J will be 1. And L1 S1, it will give 1 plus 1 to 1 minus 1. So J will be 0, 1, 2. Similarly, for L equal to 2, L equal to 2, S equal to 0, J will be only 2. But for L equal to 2, S equal to 1, it will be 2 plus 1 to 2 minus 1. 2 plus 1 is 3, 2 minus 1 is 1. So J will be 1, 2, 3. Now L equal to 3, S equal to 0. So J will be only 3. Again, L equal to 3, S equal to 1. It means it will be 3 minus 1 to 3 plus 1. 3 minus 1 is 2. 3 plus 1 is 4. So it will be 2, 3, 4. 2, 3, 4. So combining all, the value of J will be 0, 1, 2, 3, 4. So the correct answer is, if we take two electronic system with L1 is 1, L1 is 2, L2 is 1, then we'll be having all these possible values of J starting from 0, it will go up to 4, that is 0, 1, 2, 3, 4. So the correct option is option C, 0, 1, 2, 3, 4. I hope this is clear to everyone. Now we will move to question number 6. The question number 6 says, an electron of a free hydrogen atom is initially at the state with quantum numbers n equals to 3 and L equals to 2. It then makes an electric dipole transition to a lower energy state. Which of the following states may be possible after this transition? Options are option A, n equals to 2, L equals to 0. Option B, n equals to 3, L equals to 1. Option C, n equals to 2, L equals to 2. Option D, n equals to 2, L equals to 1. So these are the four options. Initially it is at n equal to 3 and L equal to 2. Then it will make electric dipole transition to a lower energy state. Then what will be the final state, and what are the quantum numbers of that final state, that is what are the values of n and L for the final state after the transition. So I'll give a few minutes to try this question, then we will discuss about the dipole transition and what is the correct answer. So an electric dipole transition is basically a transition of the electron which occurs between two energy states of an atom, and that is influenced by the external electric field, and it is the most common type of transition. So there are a few selection rules that the two states, that is the final state and initial state, should obey, so that the transition between the two level can be a electric dipole transition. So what are the selection rules? So selection rules for electric dipole transition. So for orbital angular momentum, how should it change? Orbital angular momentum delta L should be plus minus 1, so there should be change. For example, if it is S, then the transition can be from P to S, P to D, or D to P. But S to D and D to S is not allowed, because they violate the selection rule of delta L equals plus minus 1. We know for S, L is 0, for P, L is 1. So in all these transitions, delta L changes as plus 1 or minus 1. So the transition can occur only between these levels. And talking about the change in magnetic quantum numbers, so for magnetic quantum numbers, it will be delta m equals to 0 or plus minus 1. But in our question, there are no magnetic quantum numbers given. We only have n and l. However, for your understanding, let's discuss some other properties also. So also there is change in parity. Again, we can say parity is related to the value of L. So parity also changes, means since L is changing by plus 1 or minus 1, so there will be change in parity. So there will be change in parity, that is odd parity to even parity or even to odd parity. And then talk about spin. Spin should remain unchanged, that is delta S is 0. So triplet to singlet transition, doublet to doublet transition, or triplet to triplet transition is allowed, but singlet to triplet, singlet to doublet, or doublet to triplet transition, these are not allowed. So only the transitions in which the multiplicity remains the same or the multiplicity remains fixed is only allowed. So the spin orbit coupling is not involved here. There will be only the value of change in L and M, no change in S. So talking about the problem here, it is saying the initial state. So initial state, N is 3, L is 2, isn't it? N is 3, L is 2. Now what will be the final state? And the question says is the electric dipole transition to a lower energy state, and we know for lower energy state, for as long as the value of n remains the same, the energy remains the same. So the transition to occur to a lower energy state, the value of n should be lowered. So the value of n should be lower means final state will be having n less than 3, because lower energy state, the transition occurs to a lower energy state. So n should be less than 3, and again L should be 2 minus 1 or 2 plus 1. So 1 or 3. So n is 2 or 1, L is 1 or 3. So if you see the possible options, then which of the option uh, satisfies our requirements? N is 2, L equal to 0, n is 3, L equal to 1, n is 2, L equal to 2, and n is 2, L equal to 1. So n is 2, L equals to 1. So n is 2, L equals to 1 is the correct option. So n is 2, L is 1. This is the answer. So for an electric dipole transition, the final state will be having lesser value of n, and the value of orbital angular momentum of orbital quantum number will change by 1, which will be from 2 to 1. So the correct answer is n equals to 2 and L equals to 1. I hope this is clear to everyone. Now we will move to the seventh question. The question says a three-dimensional polar coordinate system is shown below. For the coordinate system, we can write. So basically, we need to convert. If we are talking about the relationship between orthogonal coordinate system and spherical polar coordinate system, then what will be the relationship between the two coordinate systems? So cos theta equals to x divided by x square plus y square plus z square root over, and sin phi is equals to z by x square plus y square plus z square root over. Then option B, option C, option D. So these are the four options. So what will be the correct relationship between the two coordinate systems? So I'll give you a few minutes to think about this question, and then we will discuss what will be the correct conversion formula when we are converting the when we are converting the coordinate system from orthogonal to spherical polar coordinate systems. And also we will discuss how we need to convert the coordinate systems from one coordinate system to another coordinate system. So let's discuss this particular problem. So as you can see, so let's first discuss why we need to convert the coordinate system. So this concept comes into picture when we discuss the hydrogen atom, because we know atom as general it is spherical in nature, but since we want to treat the atom, so we need to solve the equation of motion of particular atoms. So if we are considering a spherical polar coordinate system, then it will be easier for us to describe the whole system, because the atom is generally we have taken spherical in nature. So that's why we need to convert from one coordinate system to another coordinate system. For example, if we consider a particular, there are another coordinate systems like uh, mm, uh, planar coordinate systems, like polar coordinate systems, where only two-dimensional things we can describe. Suppose the particle is revolving in a certain circular orbit, and that is a plane, so we can apply there polar coordinate systems which have coordinates r and theta. So by using these two values r and theta, we can explain the total or complete uh, positions, or the available positions the particle can be present at. So if we are talking about hydrogen atom, since it is a three-dimensional case, so if we take spherical polar coordinate systems, then it will be easier for us to describe the dynamics or the mechanism of the hydrogen atoms, how the things get changed when the hydrogen an electron revolves in an hydrogen atom. So let's consider this particular case. So here you see, this is, suppose this is, so this is x, this is y, and this is z. So this is a vector OP. So this is P, this is O, this is P. So now let's first discuss about this only. So this is theta. So this is theta means, if we talk about the resolution of vector components, we know, suppose this is a two-dimensional space, and this is a vector. Suppose this is OP, this is Z, and this is X. We can take. So if this is theta, then this component is called as cos theta, and this component is called as sin theta component. So if the total length is suppose r, it will be r cos theta and it will be r sin theta, is not it? So similarly here, so since this is r given, so this is r, then its projection on z axis, because it makes an angle theta with the z axis. So this projection, that is from here to here, this value will be r cos theta. Similarly, the projection in another perpendicular direction, that is, since here this was perpendicular, so z perpendicular to x or perpendicular to y, but here since it is a three-dimensional case, so this xy plane, this whole plane is perpendicular to the z axis. So the projection of this r vector in xy plane will be nothing but r sin theta. So let's draw the picture again. So this is z, this is r, this is theta means the projection, this one. So this is r cos theta, and this projection, that is this one. This is r sin theta. This is x, this is y. Now again it says this projection makes an angle phi with x axis. So it makes an angle phi with x axis. Now let's consider the two-dimensional case. So this is x, this is y, and this is the vector we are talking about, and this has the value r sin theta, and this is phi. So this component, like the projection, there will be two projections, one in x axis, one on y axis. So this component, this will be r sin theta cos phi, and this component will be r sin theta sin phi. So this is x, this is y, and this is z. So if we convert the Cartesian coordinate system to spherical polar coordinate system, then what will be the relations between x, y, z and r theta phi? So x will be r sin theta cos phi, y will be r sin theta sin phi, z will be r cos theta. So these are the relations. So now our question says, so these are basically, so these are Cartesian coordinate systems and this is spherical polar. But in our question, spherical polar coordinates are on left side and we need to express those coordinates in terms of Cartesian quantities. So very simply here we can say cos sin phi by cos, if we are dividing y by x, so r sin theta will get cancelled out. Sin phi by cos phi will be x by y. So sin phi by cos phi will be y by x. So tan phi is y by x, or phi is tan inverse y by x. And what about theta? We know x square, if we are doing x square plus y square, then x square plus y square will be r square sin square theta cos square phi, r square sin square theta cos square phi plus r square sin square theta sin square phi. So r square sin square theta will take as common, cos square phi plus sin square phi, so it will be r square sin square theta. So x square plus y square plus z square will be r square sin square theta plus r square cos square theta, that is equals to r square. So another formula is x square plus y square plus z square equals to r square. Then, but here it says we need to find out the value of cos theta. So how we will get the value of cos theta? It is very easy to get. So z is r cos theta. So cos theta is nothing but z by r. Z by r, we know r square is this much, so it will be x square plus y square plus z square root over. So cos theta will be z divided by x square plus y square plus z square root over. So this is cos theta, this is phi tan inverse y by x. So if you see the options, which will be the correct one? Option B will be the correct option. Cos theta will be z divided by x square plus y square plus z square, and tan phi will be y by x. So these are the so these are the two correct answers. So the correct option will be option B, and I hope this is clear to everyone. Now we will move to question
Yes,
number 8. Yes.
yes, sir.
So we will move to question number 8. Question number 8 says an operator minus d by dx square operates on an eigenfunction phi x equal to a e to the power ix, where I is the root over of minus 1 and a is the constant. What will be the eigenvalue? Options are option A 0, option B 1, option C a, and option D a square. So Since you have joined late, so let me explain what is basically what do you mean by eigenvalues and eigenfunctions. So in quantum mechanics, all physical quantities are expressed in terms of operators. So there are some operators, when they gets operated on a particular state, the state doesn't change and we get a particular value. So for example, suppose there is operator A. So if A is getting operated on an state on a state phi, and it is again producing a value A and again that state, then this particular equation, this equation which has the form A cap psi equals to A psi, is called as eigenvalue equation, where A is called as eigenvalue, psi is called as eigenfunction. So what will be the eigenvalue if we are operating that operator? So the operator here A cap is minus d by dx square, or d square by dx square.
X square.
Exactly. So it will be d square by dx square, not d. So the operator is d square by dx square, and psi is a e to the power ix. So I'll give you a few minutes to try this and tell me what will be the eigenvalue.
Sir,
Yes.
sir, one small general question. Uh, so far, when we are practicing in mathematics and all, our teachers used to put that exponential term, and they used to put that log terms and all. But we haven't get cleared why where we are using that exponential, and where we are using, and for what purpose we are using that exponential and log and all. For integration and differentiation, we came to know for what purpose we are using that. For E and all, what is the reason for using that exponential term, sir?
Basically, if you see, uh, if you talk about the exponential terms, the basically exponential terms, all the things we try to express it in exponential term, because the mathematical calculation will be relatively easier for us. Because if you see, the difference, the if we differentiate an exponential function, it is again an exponential function. If we integrate an exponential function, it will be again an exponential function. So in order to uh, avoid some complications while solving a mathematical, because if you see, simple math is quite simple. If you study general math, then that can be pretty simple. But if we are discussing about some physical systems and we are expressing the physics of that system in terms of mathematics, then it becomes quite complicated. So if we take a particular function which has a simpler form, and it again uh, remains the same whether you differentiate it or integrate it, then it will be easier for us to deal with that particular problem. So for most of the calculations, if you see, for most of the things we generally take either sine cos and then exponential, because you see, the derivative of sine is cos and the derivative of cos is sine. Similarly, like that, for exponential also, the derivative and integration both remains the same. The function doesn't change its form. That's why most of the cases exponential functions are used.
Okay, sir. That is, the values should not be changed. For that, for simplification, we are using exponential.
Exactly.
Is it
If
correct,
we are
sir?
exactly if we are doing calculations, the values will change. Obviously, the values will change. The form of will not change. The exponential function, the nature of the function will not change. That's why our calculation will again become simpler. So if you see this particular problem, so it is d square by dx square. So we know psi is a e to the power ix. So d by dx of psi x is I into a e to the power ix, and d square by dx square psi x will be again I into a e to the power ix. So minus d square by dx square psi x equals to I square a e to the power ix. So you see a e to the power ix is again getting again coming out on the right hand side. So you can write it as I square psi x. So minus d square by dx square psi x is I square. You know I square is minus 1, is not it?
Yes, sir. Yes,
Yes.
sir.
So it will be minus I square. So minus of minus 1 psi x, that is 1 into psi x. So if we compare it to the form of the equation a cap psi equal to a psi, then what is the value of a here? The value of a here is 1. So the eigenvalue is 1 in this particular case. So for our problem, the eigenvalue is 1. So our answer is also 1. Is this clear?
Yes, sir.
So our correct option will be option B, that is 1. Now we will move to the next question. The question says, question number 9, a one-dimensional potential well of length L has following boundary conditions where Vx is 0 for 0 to L and Vx is infinity for other values. Now the energy of the particle of mass m in this well in the nth state, and these are the options: n square h square by 8 ml square, n square h cross square 8 ml 8 ml, h cross square by 8 ml n, or h cross square by ml square into n square. So these are the four options. So basically this particular question we and not this particular question, but we have solved a few problems in this interaction session also, some initial problems that was again based on the calculating the value of energy. There we are directly putting the expression for energy, but here we need to find out what will be the energy or what will be the expression of energy when the particle is present in a one dimensional potential well. So if you talk about the one dimensional potential well, it has the form Vx is equals to 0 for x lying between 0 to L and Vx equals to infinity for x less than equal to 0 and x greater than equal to L. So how it will look like? It will somewhat look like this, where these are infinity, this is 0, this is L. So x is along this direction. So from 0 to L the value is 0, and then other values are infinity. So this is basically called as a one dimensional potential well, one dimensional infinite potential well. So the name is one dimensional potential well. So potential, why it is called as well? Because since the potential are infinity on both the sides, so the particle actually can't escape that particular system. That's why it is called as an well. So how we will solve it? So basically in quantum mechanics we solve Schrodinger's wave equation for this particular case. So according to Schrodinger wave equation, the equation is minus s square by 2m d square psi x by dx square plus vx psi x equals to e psi x. This is the Schrodinger's equation, but here Vx equals to 0, so the equation becomes minus h cross square by 2m d square psi x by dx square equals to e psi x. So if you write it, it will come out to be d square psi x by dx square plus k square psi x equals to 0, where k, what will be the value of k? K will be 2me by h cross square root over. So this is basically a differential equation and it has a solution. Psi is a sin kx plus b cos kx. But we don't know the value of a and b. So how we will calculate the value of a and b? We will put boundary conditions. So according to the problem, when x equals to 0, Vx is infinity. So when Vx is infinity, psi x becomes 0. Similarly, at x equal to L, Vx is again infinity. So psi x becomes 0. So putting the first case, So psi x equals to 0 equals to a sin kx plus b cos kx. What is the value of k? The value of k will be, sorry, when, so you see at x equals to 0, sin 0 is 0 but cos 0 is non-zero. So here, since cos 0 is non-zero, so in order to make psi x equal to 0, we have to take b equals to 0. So now the wave function becomes a sin kx. Now at x equal to L, psi x equal to 0. So at x equal to L, psi equals 0, it gives us k is equals to n pi by a, or ka or n pi by L, not a L, because sin, it will give us sin kl equals to sin n pi. So kl equals to n pi, or k is equals to n pi by L. And if we talk about the energy, we know the energy of a particular particle is given as E is equals to P square by 2m, because since there are no potential energy is 0, so total energy is equal to kinetic energy. P square is nothing but h cross square by k square, h cross square k square by 2m. So h cross square by 2m, k is n pi by a square. So it will be n square pi square h cross square by 2m a square. Sorry, it will be, sorry, it will not be a, it will be L. So it is n square pi square h cross square by 2ml square. And again we know h cross is nothing but h by 2 pi. So if we put that, it will be n square h square by 8m l square, because h because uh, this pi square and this 4 pi square, they will get cancelled out pi square, then it will be 2 into 4 8 ml square. So the en will be either n square h cross square pi square by 2ml square, or n square h square by 8ml square. Now if you see the options, it is n square h square by 8ml square. So the correct option is option A. So this is the correct answer, and the correct option is option A. Is this clear to you?
Yes, sir. Yes, sir.
Okay, so now we'll move to the last one. The question says the normalized wave function of a particle trapped in a box of length L is given as psi nx equals to 2 by L sin n pi x by L. Find the probability of finding the particle in that box in a region from L by 4 to L by 2 for the fast excited state. So for the fast excited state, n is 2, because for ground state n equals to 1. So then for the fast excited, it will be n equals to 2. So if we put n equals to 2, then what will be the expression, or what will be the wave function? The wave function will be psi 2x is 2 by L root over sine 2 pi x by L. And you know, to calculate the probability will be L by 4 to L by 2 psi x mod square dx, that is L by 4 to L by 2. So 2 by L root over square will be 2 by L. So 2 by will come on out. We can take it outside of the integration. Then it will be sine square n pi x by L dx. So we can sine square x. We know sine square uh, x is 1 minus cos 2x by 2. We will use that formula. So if you use that formula, it will be 2 by L integration of L by 4 to L by 2, 1 by 2 of 1 minus cos 2n pi x by L into dx. So if you solve the integration, it will be 1 by L x minus L by 2n pi sine 2n pi x by L by 4 to L by 2. So if you calculate, it will give you 1 by L, then L by 2 minus L by 2n pi. So 2n pi means n equals 2. If you put, it will be 1 by 2 into 2 into pi sine 2 into 2 pi into L by 2 by L minus L by 4 plus L by 2 into 2 into pi sine 2 into 2 pi by L into L by 4. So if you calculate, it will give you 1 by 2 minus 1 by 4, that is 1 by 4. So if you make it into percentage, it will be 1 into 100%, that is 25%. So the correct option will be 25%. So the probability of finding the particle between the distance L equals to L by 4 to L by 2 is 25% in the fast excited state. So when we put n equal to 2, we will give it will give you 25%. So 25% will be the correct answer. Is this clear to you?
Yes, sir. Yes, sir. Thank you, sir.
Okay, so with this, we come to the end of the today's interaction session. So basically today I discussed a few problems that are based on week 6 interaction, week 6 lectures of the course. It covered some introduction to quantum mechanics and a few problems that are related to the LS coupling. LS coupling basically it occurs in case of multi-electron atoms. Also some uh, selection rules were also discussed for electric dipole transition. Again, if we are talking about LS coupling, that generally occurs in case of smaller Z elements, we tried to solve a few problems. We tried to calculate the possible values of Z correspond to value of L and S that was given to our problem. Then at the beginning of the session, I gave some brief idea about quantum mechanics, how it got evolved, and what are basically some of the postulates that we uh, take into account in quantum mechanics. So I hope this will help you in your preparation of your exam and in solving your assignment questions. So that's it from my side. I hope I have um,
Sir,
explained the
sir,
questions.
excuse me, sir. Excuse me, sir.
Yes,
Sir, initially I missed your class today. Sorry for that. And
it's okay. So
I thought of asking two basic questions when you come for this quantum.
yes,
That is generally your perception is always very clear. For that purpose only, I'm asking you, sir. What is the meaning for quantized and what is the meaning for discrete according to your perception, sir?
no,
Because
discrete.
I
Yes,
it is
basically
quantized
discrete,
and it is
dis-
um,
discrete and quantized both are equal. So when we talk about discrete means it is not continuous. Not continuous means it is quantized. That is the main thing. If you talk
continuous
about
means
continuous means it is not quantized. Quantized means it is discrete.
for example, 1, 2, 3 is said to be continuous or 1.1 that is the fractional value is going to be continuous, sir. So
Exactly.
what
So
we are saying
1 minute. So what we discussed